So this video is all about calorimetry and most things that are associated with it, mostly heat and such. And so first we're going to look at the basic setup for a calorimetry lab or anything that you do. And since it's mostly based on heat, you're going to have your heat source, which is more than likely going to be a Bunsen burner or some stand that you can hold your calorimeter on. And so we're going to look at a basic calorimeter right now. And in a basic one, you're going to have your solution set up in the middle of the entire thing, surrounded by an insulated airspace. And this insulated airspace is used to sort of save the amount of heat that would go to any other sort of source other than the solution. And it would also maximize the heat that goes to your solution. Now you would insulate it by using insulator rings around where the solution is held, and by using an insulated lid on top of everything with enough holes to have your stirring rod and your thermometer go in it to make sure that the heat rises at the appropriate amount that you want to get. So when you're doing any lab dealing with calorimetry, you're going to be dealing with something called enthalpy, and that's sort of like a measure of heat energy. And so we're going to look at the basic equation for it, which is delta H equals MC delta T. And in that, the variables stand for multiple things. Delta H is your enthalpy in joules. M is your mass of your solution in grams. C is your specific heat in joules over grams degrees Celsius. And your delta T is going to be your change in temperature, final minus initial, in degrees Celsius. And the big thing about this is that delta H, M, and delta T all apply to sig figs. The specific heat doesn't, because it's a constant and it will never change for any sort of substance, but it's always going to go with one substance. Equation you would use to calculate enthalpy, we're going to look at a sample calculation for how you would get enthalpy. And so our sample problem is going to be this. 1.500 grams of salt dissolves in 75.00 milliliters of water in a calorimeter. The water temperature decreased by 0.9300 degrees Celsius. Given the specific heat of the water is 4.184 joules per grams degrees Celsius, solve for the enthalpy of the solution. So first, we're going to start out with what we know from this equation. And what we know is that the mass of the salt is 1.500 grams. The mass of the water is 75.00 milliliters, or 75.00 grams, because 1 gram is the same as 1 milliliter. The temperature change is going to be negative 0.9300 degrees Celsius, because it said the temperature decreased. And the specific heat, which was given to us in the question, is 4.184 joules per gram degrees Celsius. So when you go to solve this problem, you're going to plug in all of the variables that you know into the equation that you already know. So when you do this, you're going to end up getting delta H equals the mass of the salt plus the mass of the water times the specific heat of the water times the temperature change. And once you go through this work, you're going to get that the total mass is 76.50 grams, and the specific heat times the temperature change is going to be negative 3.89112 joules per gram. And once you solve this out, canceling out all the units and everything, you're going to get delta H is negative 297.671 joules. But when you apply sig figs, you don't get 4 from here, because that's a constant. It wouldn't change for the water. You're going to get 4 from here, here, and here, which would get you to delta H equals negative 297.7 joules.